All right, so let's talk about recognizing reduction and oxidation. This is something that is going to be on your final exam. And actually, if you're looking, if I'm not your professor but someone else is, I would still wager that this will be on your final exam because it's a super common concept. All right, so recognizing oxidation and reduction. So oxidation is essentially the increase of oxidation state, and reduction is the decrease of oxidation state. And so if you know how to do oxidation state and you've demonstrated mastery of that, Alex will let you attempt this one. So what I've done is I've taken a snapshot of this and I've put it over my whiteboard. Let's go over there right now. So here's the snapshot of it, and it's my whiteboard. I'm going to make some notes on here, okay? I'm going to do the top one. Let's say do the top one in green. And so let's find the oxidation state of hydrogen here and hydrogen here. And if it goes up, it's oxidized. If it goes down, it's reduced. And if it's neither, right? So we know that when, according to rule number 1, if it's an element, or that's actually rule number 2, if it's an element, then its oxidation state is 0, okay? And if it's not an element, but it's a compound, then we have to go with the other things that we know. So we know that oxygen is -2 because its main group, it's in the 6th column, so it's -2. And we also know that the sum of all these oxidation states is going to be 0, right? -2. And so this must be, because we've got 2 hydrogens there, right? So that must be +1. Can you read my writing? So this is +1. So it goes from +1 to 0. And since it goes down, that is a reduction. All right? So let's do oxygen here. We just said over here in water, oxygen is -2. Let me switch colors. Let me go to blue. It's -2 in water because it's a main group element. And over here it's elemental, so it's 0. So going from 0 to -2, that looks like that is also a reduction. Agreed, from 0 to -2 is a reduction, and from +1 to 0 is a reduction. That's a little confusing, right? I expected 1 to be an oxidation, but it's not. And we did that right, so let's move on. Oh, by the way, up here we're going to be circling, we're going to be filling in that bubble, right? We're bubbling that in. On Alex, all you do is click it and it goes in automatically, right? Okay, so let's go over here now. Let's go to the next one. I'll go back to green so we don't get these confused. This is +1 because it's main group element. And so there must be a total of +2 because there's 2 of them, right? Plus something equals 0 because there's no charge on this, right? So that must be -2. And sure enough, it's main group element also. So it's -2, no big deal. This is also +1, and there's 2 of them, so it's going to be +2 plus something gives 0 because they all have to sum to 0. And so this must be -2 again. So it looks like there, from -2 to -2 is neither. Okay, let's move on. One more. All right. So rule number 1, according to the rules that we learned about assigning oxidation states, this is an atomic ion. And so its charge is its oxidation state. So this is going to be -1. And rule number 2 says if it's elemental, it's going to be 0. So it looks like it's going from -1 to 0. And that goes up. So that's an oxidation. All right. So those are our answers. It looks like it's reduction, reduction, neither, and oxidation. Let's go back over to the live. It was reduction, reduction, neither, and oxidation. Is that right? Hydrogen's +1 here and 0 here. Oxygen is 0 and it goes to -2. That's also reduction. That's true. Sulfur's not changing. -2 to -2, so it's neither. Yep, this is correct. All right, let's go ahead and submit that and get the green ink on there. Love it.